And anybody who has any comments or questions or can't hear me or anything like that, please feel free to type something in the comment window. If somebody wants to put something in right now just to make sure that you can see my screen and that you can hear my voice, that would be much appreciated. There we go. They can hear us, and that's a good start. So the purpose of today's webinar is realistically, we're just trying to ensure that we're having a conversation. That MAP 21, these NPRMs have now been out for a couple months. A lot of states have been doing some research into the subject. Some people have spent a significant amount of time working on them, some more than others. And I've been getting a chance to get out, and I probably visited, I think it's about 6 or 7 states, so I visited many of the people that are on the phone. And what we've been trying to do is figure out how many people have gotten involved, what questions, concerns do people have, and some of the most important stuff that we're concerned about is making sure that people are involved, they understand what the requirements are going to be, and if there are questions and concerns, that people are raising them, and that they're getting these questions and concerns submitted to the docket. This is the biggest key, is making sure that this information is getting read, reviewed, and that it will get addressed in the long term. We're going to try and hit some brief highlights of the overall process, but I'm going to primarily try and stay in the pretty detailed. Many of you have probably attended a few webinars now at this stage, and not surprisingly, at Fugro, we're going to try and focus a lot on the pavement data collection side of things, and that's really what I'm going to try and focus on. Some quick instructions is we encourage people to submit questions and comments throughout. We're definitely going to have a discussion and question period at the end. If there's a question that we can address as we go through, we may try and do so as well. The first part of this is I'm going to do some quick review and provide some of Fugro's perspective on MAP 21 and some of the issues that we're trying to raise, as well as encourage you to address and comment on some of these things as well. And then we're going to hear from Mark Suarez of Louisiana DOTD. He's got some stuff. He's done a lot of good work on trying to show some of the issues that he's been having with the faulting data, as well as some of the cracking distress data. And then we're going to try and open it up a little bit. I know a few of you have been contacted in the last couple of days asking if you'd like to share some input into the system. If you do have any questions or comments, or when you are ready to speak and we get to this stage, please just send us a quick note in the chat window, and at that point in time we can make sure that you're unmuted and that you will actually get the opportunity to talk. Otherwise, we're trying to keep everybody on mute, just to keep the background noise down, and just so we can keep this going and reduce the number of distractions.
Can everybody see the presentation?
Nope, it doesn't look like it.
Hello.
Hello.
Smart.
There we go. So we do have the ability to make sure everybody can see it. I'm going to hit the show my screen. There we go. Now we can see the agenda, and that means we're ready to go. Perfect. So as I said, this is the brief kind of outline of what we're going to have, and we are trying to make this interactive. You guys, some of you have already listened to me, and we're more than capable of submitting our own comments. What we want to do is make sure that everybody is talking to each other, and that's really the big goal that we're trying to get out of today, is make sure that everybody knows what everybody else is up to, and that common issues are being raised and raised often to make sure that they are going to get addressed in the final set of rules. All right? So starting with that, I'm going to commence and talk a little bit about our review of the performance measures rulemaking. Overall, I'm not going to talk too much about the data collection requirements. I think the expectations are relatively clear in the NPRM, exactly what they expect in terms of mileage. I know a lot of states have been granted extra NHS mileage in the last little while that has to get added in. I know several agencies have already voiced concerns about having to increase the amount of collection, either in terms of cycles or in terms of extra miles that they're collecting, but that stuff is relatively clear. Some of the stuff that I think is a little bit more contentious is one of the things is the first performance period is expected to begin as of January 1st, 2016. So realistically, we're mid-August. So we're not talking that far away. We're talking 7.5 months before this collection period starts, and we're not really even sure exactly what we're going to be collecting. We know what's proposed, and we're all interested to see how it's going to change to make sure we're ready for that January 1st date. It is phased in, and this is one that it took me a little bit of reading to try and figure out where it showed this. That's why I gave the number there at the bottom. But realistically, the first 2-year cycle, you're only obligated to submit your usual HPMS delivery requirements. The problem is at the end of the 4-year cycle, you will be required to meet all of these national performance measures. And so that means you pretty much should be starting to try and collect them at the beginning of January 1st, just to make sure you have that information. And the biggest reason why you're going to need that information sooner rather than later is because you still need to set goals based on these things. And if you're not testing them and you're not trying to measure them relatively early on, you're going to have real difficulty trying to set those goals, never mind actually meet them. So I'd say that that's one of the biggest highlights early on is the calendar and the schedule and how quick it's going to go by. Missing data is another contentious one. Specifically, anything that is not reported is going to be considered in poor condition. However, we've seen in a lot of the data deliveries that we provided to you guys, as well as for anybody who's collecting their own data, there is a lot of data that does get either invalidated or oftentimes removed from the analysis. And there's lots of valid reasons to not want to trust the data even though you have collected it. Some of the more common ones are low-speed roughness. And while this doesn't necessarily apply to the interstate network, it will definitely apply in a lot of your urban areas. Construction zones. This is probably one of the biggest ones on many of the interstates, where if you have a 20-year cycle, that means probably about 5% of your road network is going to be under construction at any given point in time. So if you don't generate information on that 5%, well, there's your 5% poor. That's set as your mandated rule in terms of your interstate collection. Well, it doesn't apply to everybody. Border crossing military facilities. When we're doing data collection, or if you're doing the data collection yourself, there's definitely a whole bunch of areas that people don't necessarily want the video cameras and the measuring technologies. So how big of a buffer can we leave around these, and are they just going to get classified as being poor? There are, of course, other exceptions. While there is still some discussion in the document about being able to temporarily leave that outside lane, how long is that going to last for? And there are always some temporary problems with the equipment. And while we do the surveys, we obviously do our best, but there's typically an exception list, and people who collect the data themselves, they oftentimes struggle with the fact that a piece of data isn't good and whether they want to go back out and recollect or just accept a gap this year. So how are these things going to be dealt with? The actual documents talk about the reason for this rule is that quite a few networks have not been submitting all their data. And they're not necessarily talking about not submitting 2 or 3% of their network. There's large chunks where they haven't even submitted parts of the interstate network. So that's the main reason for this rule, but currently it's very rigid. There is no room for flexibility, and yet there's oftentimes these things that are going to come up. We expect them to come up, and we probably need some clarification exactly how these can be dealt with. And we can go back and recollect and keep collecting until these are done. Obviously, we want to work with you if you know where your construction zones are going to be in advance. How can we plan to accomplish this beforehand and try and get this information as much as we can in advance to reduce the impact of these? But if we can't remove them, how are we going to address these issues? And whether it comes out as a buffer zone where there's a certain percentage of the road, but it's all right if it's not necessarily provided the information, maybe 2 or 3%, up to 5% based on how much is reasonable to expect to be missing on an annual basis. But this is the kind of comment that I think is very fair, because every state agency is going to face this no matter what their data collection process actually is. One of the next big issues that we're going to face is data reporting. Everything's in 1/10 of a mile, and it's tough to give an exact number, but it's probably around half of our customers are currently getting 1/10 of a mile and don't have to change the reporting sections. There are definitely some that have smaller increments, and there are definitely some that have larger increments. while it may not necessarily be that difficult to give two tables in the case where there is a change, that way some consistency can still exist from year to year, as well as we can still continue to meet these reporting guidelines. So the questions are still going to come up as to how do we break these things. This is one of the biggest ones, and I stole this picture at the bottom from a presentation done at the Southeast Pavement Preservation. And so what it becomes is there's a couple things where we know we're going to have some challenges in reporting some of the data. The two biggest ones that this chart clearly shows is, first of all, there is some guidance in there saying that we do not have to report some of this data on bridges. And it doesn't take much looking at your network to know that roughness always spikes on bridges, primarily due to the existence of approach slabs, leaf slabs, and all the expansion joints that occur on the bridge. So we know these are going to be spikes, and they're probably going to be above that limit, the threshold to become poor. So that's a known issue, and so they've addressed it by saying we don't need to report issues on bridges. And that makes sense as well, because clearly you're not going to necessarily have that much cracking on the bridge decks. The surface material that's there is not necessarily thick enough. But the problem is how do we remove these bridges? There's a couple solutions, things such as roughness, for example. These are measurements that don't take place at a single point. Roughness is measured over a length. And the actual roughness algorithm typically looks at lengths between 3 feet and 300 feet with various different weighting factors based on the actual wavelength of the roughness detected. So the problem becomes, if we have a bridge in the middle of a section, how do we deal with that? How do we take an IRI for the beginning portion and the end portion and take an average of that? Do we have to remove the actual profile data that's on top of the bridge? These are some challenges. The other challenge is how are we going to deal with pavement type changes? And this is shown as well in this chart here, where we see a transition from an asphalt concrete pavement. Here's another option at the bottom is, do we have to reset a section? Then all of a sudden we have sections that are shorter than 0.1 of a mile. But what is the tolerance? Because clearly if we only have a section that is somewhere between 3 to 6 feet in length, and you have just a small patch of alligator crack in the area, some of your numbers can be highly, highly skewed. The sample area definitely can have an influence, specifically when random localized distresses are encountered. Does that mean we split it here? Does that mean we try and calculate the percent cracking for the asphalt pavement and then percent cracking for the concrete pavement and do a weighted average based on the area? These are some of the issues that are not yet clearly understood, and I think more guidance needs to be provided in order for us to make some decisions. As well as how are we dealing with these things at spots like county lines. Oftentimes, new locators, new highway are defined in milepost reset, and yet the rules are pretty clear that they want you to keep 0.1 mile sections from the beginning of the road to the end. Well, is the road defined to end at that county line? There's not a lot of clear guidance yet. One of the biggest issues that I think we've spent a lot of time on is trying to interpret the standards. And this is something that I don't think I can emphasize enough. I encourage all of you to actually make sure that you have read all of the cited standards. Specifically, there's a couple of them. First of all, how to measure percent cracking. This is one of the biggest ones. The phrase percent cracking does not actually appear in the referenced AASHTO standard specifically for the fully automated. It talks about how to measure the length of cracking in feet by road zone, by severity, and by type, but that does not necessarily represent a percent cracking. You can look at some of the other sources that are also referenced. I've got a copy of the HPMS field manual in front of me. And pretty much for the asphalt paving, it just uses a percent fatigue cracking. And while that may be adequate and it's not necessarily difficult to measure, the question then becomes, how have you historically measured this distress? And is this something that you want in addition? Or is this something you're going to start to change and modify pavement management systems to address these kinds of issues? In terms of JCP, percent crack slabs is probably relatively clear. The only key is we start getting into definitions of, well, what counts as a crack slab? If you have partial depth cracks, if you have corner cracks, if you have things such as decracking or durability cracking, are these going to count as a cracked slab? While not necessarily difficult, any way that the rule comes down, clarification is needed to make sure that we are being consistent and this is getting applied the same way for all states. ERCP is probably the one that is the least clear. While they reference many of the standards, it's not clear how to determine percent cracking at all. They do reference that things such as pop-outs and spalling are to be used in terms of percent cracking, but we're not exactly sure. Does that mean we're just taking the area of the pop-out? Are we taking it as a percent of length? There's a lot of gray area here, and it's not well referenced definitely in any of the AASHTO standards exactly how to deal with that. The rutting standard is actually relatively straightforward and not necessarily difficult to apply. The biggest issue that many states are going to face is it's not what they're currently using. Most states have some sort of internal practice that they've been using for many years to either simulate a straight edge or to simulate a wire rutting method, and that is not what is used in the referenced AASHTO standards. There's actually two referenced AASHTO standards in terms of the rutting. The first one is to use a 5-point rutting system, and some states have this data and it's readily available. And if you have a more advanced system, it's actually very easy when we have all of this data just to pick out the referenced 5 points and calculate it. There's still a couple issues as to where should those 5 points be located? How many profiles do you need to take? These are things that are still optional and will impact the values you get. In terms of using the whole profile, I would definitely encourage you to read this. Pretty much it is a modified version of the 5-point. It is not using a simulated straight edge or anything remotely like that. In actuality, what it is doing is it's telling you to take an average value in the center of your roadway, an average value of a range of your profile in both of the wheel paths, as well as on the outside. And then it uses a bit of a rotation scheme in order to determine what the rut depth is within the wheel paths and how to try and determine if there is a center rut rather than in the two-wheel path. So it's definitely a very different system than what many agencies currently are getting reported to them. Once again, that doesn't necessarily mean it's bad. It just means it's going to be different. And so be prepared that if you're reporting this, you may want to also continue to get your other data reported separately. In terms of roughness, this is one that different agencies had different amounts of questions about. Some seem to be pretty okay with it. A lot of agencies, specifically the southern ones, who are less likely to be dealing with the transverse cracking issues as regular, the thermal cracking, or the ones that don't necessarily have frost heave issues as well. It's just important to realize, though, how the IRI is calculated and what this can be impacted. So first of all, it's important to keep in mind that the roughness measurements are based on sections up to about 300 feet in length. So as we mentioned earlier, we still have some discussions about how to remove the bridges. Some discussion I know that's already been going on with the FHWA talks about, do we want to invalidate the whole section of road? So if there's any part of a bridge in that 1/10 of a mile, can we just remove it all? There still becomes a bit of a discussion, though. Well, what happens if the bridge starts just inside the new 1/10 of a mile section? That 300 feet we were using to measure the roughness, are we using any data, any of the actual longitudinal profile that's on the other side of that 1/10 of a mile? And that occurs either before the profile or the end of the profile. Do we want to remove the IRI within a certain distance from the bridge? So say, for example, we want to use the IRI so that way we're not within 150 feet of the bridge, just to make sure we're not using any of that profile data. If that's the case, that's fine, but just additional clarification is needed, and then the problem becomes what happens when we start to remove this data, even when we do invalidate bridges, as we've been told we're allowed to do. How is this data to be reported? Do we get an extra field called bridges that we are to report? Or I just don't want to leave the field blank, obviously, because that will get marked then as poor from missing data. The last option, of course, is to remove the actual longitudinal profile. So this one is definitely a little bit more intensive. And what happens is you have to review your data after collection, figure out exactly where that bridge starts and where the bridge stops, and then start to filter out the longitudinal profile. And once that profile has been removed, to then go back and calculate IRI and populate it within these sections. While this is definitely possible, it is definitely going to be a higher level of effort, specifically for those of you who own your own equipment, to make sure that you know exactly where your bridges start and stop, because you don't want to be 6 feet off and accidentally include something that you don't want to, because that will cause a spike in your data. So the last one is definitely not the preferred option in many cases, just because it is going to put a substantial extra burden on whoever is processing the data, whether we're helping you process the data or you're doing it yourself. Faulting. Faulting is probably one of the more controversial ones, and it's one that I've definitely had a lot of conversations on, and I know Mark's going to talk a fair bit about that. So the big difference here is this is a relatively new standard. There is an AASHTO standard. It only came out in 2013, and for many of the people on the phone, you've been receiving faulting data for many years prior to 2013. There are no other real national standards. There is no ASTM standard for faulting. There is no ISO or other international ones, really. There's a whole bunch of guidance on how it can be done, but there's very little in terms of actual standards. The actual existing AASHTO standard, which once again I do encourage you to read, primarily just uses the roughness-based system. So it's just using the laser and the accelerometer. And it's trying to identify exactly where the joints are because there's a small discontinuity in that longitudinal profile. The key is, though, is if you have a lot of smooth joints, it is very possible to not identify a joint. If it is a smooth, consistent profile, that joint just does not get detected. So what that happens, though, is if you have 2 or 3 joints that are badly faulted, this greatly brings up your average because if, for example, if you have a 1/10 of a mile section and only 2 joints are detected and they happen to have a faulting of 0.2 of an inch, and there's only 2 faults out of, say, 30 joints that were actually in the place, your average would be 0.2, which would then get marked as poor condition. However, if we knew all of those joints were there and we added in all those other joints with a faulting height of 0 millimeters, clearly that average would come way down, and all of a sudden it would be acceptable, and you would get a good measurement. So the problem becomes, how can we be sure that all of those joints are indeed identified? In many cases, the results that are being used and the process is being done, a minimum threshold is currently being implemented that removes all small faults from many agencies. And we've done this for years, long before this AASHTO standard, simply because we were afraid of false positives. And we would rather remove faults that you probably weren't going to fix and just identify a count as well as an average fault height. And then most of you were able to use this information and realize, fine, this is my average fault height, but I know I only have 2 in this section. So while it is a high number, there's really not necessarily that much faulting there, and you could deal with that successfully in your pavement management system. However, now that we're only looking at that average height, it's definitely throwing things a little wonky, and we're seeing things from a very different perspective. And because of that, a lot of people are re-looking at their faulting data. We're starting to reprocess some of this data, so we're showing it so we're not removing any of these faults, whether they're there or not. And the results are definitely looking a lot better. However, this is definitely going to be different than some of the results that have been previously reported, which is showing some concern. So real quick, I'm not going to talk too much about this one because I am trying to focus on the data collection, but I'm going to talk about the asset management plan and PRM as well. For this one, comments are due on May 29th, so you still have a little bit of time to get some comments in. This was actually added to the docket, I think, just 2 days ago. And it's trying to show how there's some interaction between the performance measures and the asset management plan. And so overall, we're expected to use this inventory and condition data to meet some of these things and get the data out. And this is just the little slide that was provided. The overall process, they make it sound really quite simple. Where step 1 is perform a gap analysis. So figure out where you're different from where you're expected to be Make sure that you're doing a life cycle cost analysis, so we're not just doing a pure prioritization, that we're actually looking at costs and how costs are going to change over time. Risk management analysis, a financial plan for a minimum of 10 years, and there's been lots of comments on the time period and how you're going to estimate budgets over that 10 years, as well as come up with the investment strategies. As I said, I'm not going to talk too much of this. One of the more interesting ones, as specifically it pertains to data collection, is there's a clause in here talking about the evaluation due to emergency events. I've listed the clause number there, but it just says that increased evaluations, so periodic evaluations of all these facilities, and making sure that you're looking at reasonable alternatives to these repeated repairs, aka they don't want you making the same mistake and doing the same overlay over again just because a road floods and becomes a problem. Or if you're fixing the same frost heave 20 times, they want to see that there is indeed a plan to prevent that and ensure that the money is going for long-term fixes, not just stopgaps every single time. And there is specifically a 2-year evaluation schedule, and while it's not exactly clear from my review, but exactly what needs to be done, how these sites are going to be identified, number one, exactly what needs to be done to ensure that this is going to happen. And just before I move on to the next section, the biggest reason that the asset management plan is worth noting is the asset management plan talks a lot about setting future goals. It talks about setting up these goals, coming up with work plans, coming up with these budgets, and then doing your very best to actually implement them. So the real key comes into here is the performance measures that are cited in the other NPRM. This information alone may not be adequate in order to complete this level of analysis. So this is the part where if you're going to be held to a higher level of accountability in terms of the quality of results that are coming out of your asset management plan, I just want to make sure during that gap analysis that people are stopping and thinking about not just the performance measures as mandated by MAP 21, but they're also asking, am I getting enough information from my existing surveys so that way I can make these decisions and meet all of the requirements for this asset management plan? And there are definitely some different requirements there. And at this stage, I'm going to stop talking. I'm going to open up the floor a little bit. Have we got a question there?
Yes.
So we've got a question. Go ahead there, Thomas.
There was a question a few slides back. Where was the rutting approach used in the industry prior to the rules?
The rutting approach used by industry it has changed substantially. Back in the days of the 5-point rutting, things were pretty clear. The methodology to calculate it was pretty clear. Then as other laser systems were evaluated specifically, you see that there are a lot of European, Australian standards for systems with stuff like 13-point lasers. In most of these, use very similar processes to what we do. The only difference is we have a heck of a lot more points. The problem is none of the AASHTO standards, and actually there are no real ASTM standards right now that do a very good job of how to process if you have 1,000 points or 1280 with some of our laser XVP systems, or if you're using the new PAVE 3D systems, we have up to 4,000 points across. None of these existing standards do a great job of how to deal with this. We have been working to try and come up with better methods that do a better job of finding the rut depth, whether it occurs in the wheel path, whether it occurs in the center of the road, or some other location within. And if you've ever seen our transverse profile data, you can see that these points actually move throughout the section, especially when you have smaller rut values. But there is no real standard. The problem we've always had is if we just report 5-point rutting, we find that we often miss a lot of the key rutting. We start using some of these older systems, we find we're not using all of the data appropriately. We find we're missing rutting where there is rutting, and where sections need to be asked, where maintenance is still required, but existing standards do not do a great job of identifying these. So that's why over many years we've had lots of discussions with many of you and set up different rutting protocols. One of the more common questions we ask new clients is, well, how do you currently manually measure rutting? And inevitably, we show up on site and somebody's holding a straight edge or a piece of wire and a ruler. And we've done our very best to make sure that we're measuring rutting the same way that you have always manually measured it. The problem is the AASHTO standards, the way they're currently written, don't try to match the manual methods. They try and simplify the automated method. So the short answer to your question is where is the rutting approach used in the industry? Is it's not well documented in industry. It's not well documented in standards. But Fugro has all kinds of documentation. If you want more information about exactly how we are accomplishing this, feel free to talk to your project manager or customer support team, and they can help get you some of this information. Right at this stage, I'm going to try and turn the presentation over to Mark Suarez. I'm going to try and change the presenter here, and we'll see if this works for Mark. And give him the option to share a screen. Can you hear us there, Mark?
Yeah, I can hear you.
Good.
You could. Why don't you just bring up my presentation? I'll tell you to advance the slide. That would be easier.
There we go. It should be up on your screen, and just tell me when to switch slides for you, Mark.
Okay, so yeah, it's definitely up on my screen. Go ahead and go to the second slide. All right, and that just kind of reinforces what DJ said a minute ago about the dates. May 8th is the National Performance Measure, so it's coming up on us pretty quick. Go to the next slide. We try to get, I had a lot of issues with the rules. I've been reading them. If you look at it, it's like 284 pages of rules or 200 plus pages of rules, and you read all the research documentation that they reference, and you're looking at probably about 4,000 pages to read. Well, studying it, they reference all this research and say this is based on research and data. When you really, really dig deep enough, you can't find the research and data that they used. And you dig deep enough, well, found out that the metrics would appear to be based on the pre-1998 data, where they use like a 10 million easel trucks instead of the more current volumes that are coming up now for pavement design. So I think the data's dated, and I think the truck volume's almost minuscule. I had a big write-up about it. I can send you all read if you want, but I'm still working on the document. But the faulting also has some issues. Traffic exploded around the year 2000. So I can't find any evidence anywhere where they updated the faulting metrics based on newer data. They used that old data. It was design-based. It wasn't field-based or reality-based. It was based on design criteria, and they just haven't seemed, to me it appears they haven't updated or haven't come past that. On page 147 in the expanded version of the notice of proposed rules, they're saying that traffic doesn't matter to pavement conditions, and I disagree totally. It's truck traffic equals pavement conditions. The more trucks you have, the worse condition of your pavement's going to be. Next slide, please. Okay, on the next slide, when it comes up, I couldn't get a grasp of the numbers they were talking about. They're talking about 0.4 inches, 0.04 inches, or 1 millimeter. 1 millimeter comes out to be pretty much basically 5/128ths of an inch. So it couldn't make any sense of that. So basically, I pulled out the coins and I looked on the web and got the dimensions of coins, and the depth, the thickness of a dime puts us in a fair category. I'll get you some coins out if you have them. Just look at your coins and say, okay, the roughness of a faulting of a dime basically is a fair fault. I don't think you can imagine feeling that with a vehicle. And 3 dimes puts you in a poor category. Try imagining feeling that with your vehicle driving over 3 dimes. I mean, you won't even notice it exists. So the numbers seem kind of goofy based on coinage. And just remember what DJ said earlier, if you find one fault in a 1/10 of a mile segment, whatever that fault is, that's your average for the 1/10 of a mile, one fault. So next slide. We decided to look at some data, some real data. Looked at some older, this is an older pavement on industrial corridor. I drive it every day. In fact, it's the road I used to get to work. Well, when you look at the real-time data, basically what they do is in the vehicle, they run real-time to set a minimum of 1-inch threshold, 1/10 of an inch threshold to kind of eyeball the data and make sure it's not way out of whack and they don't have some issue with the sensors. Now they take that data, and if you look at it, some of these guys are really using real-time data instead of paying for all the post-processing stuff, and this is the kind of numbers you're getting. The red identifies that it's in the current proposed poor category. And when they post-process that same exact data with the same minimum threshold, they eliminate all the false positives or a lot of false positives and get some better numbers. Clearly the 0 on a couple of those 1/10 of a mile segments is inadequate, but you're starting to see something that makes a little more sense. Okay, now this is this segment. The point of the slide is if you look at the 1 millimeter threshold that they set, all right, those numbers seem reasonable. You're talking about a very old pavement on industrial corridor. Those numbers seem reasonable and gives you a false sense of security that it's good data. But when you start analyzing the fact, okay, the numbers go down, compared to the real time of the post-processing because they're getting a lot more faults. They're finding a lot more faults, but they're not finding the fault for every joint. They're just finding a lot more. So the numbers look reasonable, and it kind of makes you wonder. So what I had DJ and them do was go back and look at the to identify every joint and set no minimum and run the data again. Now we're looking at the real joints in that column L, and it has no minimum. All of a sudden, those numbers are legit. I mean, that was it. Every joint had a fault, and it was measured, and it was 0. It was averaged in. So on that industrial corridor, those numbers like, wait, you got good category on an old industrial corridor? Well, we did a big joint repair on it a few years back. So those numbers are pretty much legit. Now the thing that looks, the M column, they're saying, okay, if you look over to the left on the H, they got the H column that tells you how many joints they found in that 1/10 of a mile segment. Then you get that one that has 34 joints. They found an additional 34 joints, so I'm pretty sure what they were capturing was all of the patching, the concrete patching that was done at the joints to repair them. So you basically had 3 joints along that way or something along that line. You got to investigate that. But even if we throw out that number, and don't worry about the column N because it improves the average, look at the difference in column O. Column O represents the difference between the real-time fault and the no minimum tied to joint fault. And that's the kind of number differences you're going to see. I mean, you're looking at the thousands of percent in a lot of cases and high numbers, hundreds of improvement by going to real identified joints for the minimum threshold. So identifying the real joints and capturing that, kind of gives us a clear picture that we can do better. Next slide. All right, now this is the average for that 11-mile segment, okay? And if you look at the percentages down at the bottom, basically where you're looking at real time, the road's in crap shape. We're going to get killed on it. If we post-process, it would come out a little better. If we go to the minimum threshold of 1 millimeter, it seems reasonable that 96% of the pavement is in good shape, okay? Fair shape for old industrial corridor. But if you do no minimum and tie it to the joints, you end up with about 40% in good condition, and then you get about 60% fair instead of 96%. So those numbers make you think, okay, what are we doing here? How legitimate is this real-time stuff or post-processing stuff if it's picking up all these false joints or not picking up enough joints, or it's not factoring in the 0 joints? So next slide. All right, so what we did here was we got new pavement. We have some new pavement in the state, and you're looking on the left. You got 2 miles, 2.5 miles, 1.5 miles, 2 miles, 22 miles, and 6 miles. Now we do the real time, and you look at it. The average numbers for the real time are pretty much unacceptable for new pavement. I mean, we got 68% fair and 28%, basically in the neighborhood of it's 96%. 80%, 95%, 80, 90%, 80% and then very, very high numbers that are fair and poor categories on brand new pavement in real-time faulting. So if you're using real-time faulting and these numbers stay in place, you're going to have to get away from it. You're going to have to go to a lower threshold, some kind of way, or you're going to have to go to you're going to have to get the post-processing done. You're not going to be able to stick with the real-time. If we look at the last two columns, though, it really makes a difference. You look at the 1 millimeter threshold versus the no minimum threshold tied to the joints, and look at the differences. I mean, you would, on a new pavement, on that second one, do I really have 80% of my pavement in fair or poor category on a new pavement at 1 millimeter? I'm finding it tough to believe. We have, 80%, 64%, and all these high numbers of fair or poor still at 1 millimeter thresholds. And that's when it starts to make me think, okay, there's something wrong with the way the software is working. There's something wrong with the way we're processing this data. Can we really trust it? Is it going to be valid? So when they run it against the actual joints, well, look at that. We're almost 100% on every one of them because we're looking at just the joint and the fault associated with the joints. We're averaging every single joint. Now we've got real data. And that third one, sure, we got one that has 5% in fair category because you're going to have a pavement that's not going to be just right when you do a pavement. You're always going to have some little gotcha spots. But to me, the no minimum tied to joints is it's the reality of the data. Okay, and if we stick with the metrics that they have now and we don't get to do post-processing, basically they're legislating jointed concrete out of existence. This is a legislation that's going to force us to get away from jointed concrete pavement. Next slide, please. Now, when we look at the faulting data now and we use the rutting measures, 0.2 is good, 0.2 to 0.4 is fair, and 0.4, I mean, rutting's a safety issue. Faulting's a pavement condition issue. Why would the faulting numbers be more severe than rutting numbers? I don't quite follow that, but if you look at these numbers, and you got to get your coins out. You need to cut a couple of coins and sit down with your guys that you're working with. Put a dime on the pavement, put 3 dimes on the pavement, look at their numbers and say, wait, this doesn't make any sense. Now, if you got 3 dimes on the pavement, now you're in good category. If you got 8 dimes on the counter, you're in poor category. Those look reasonable to me. Those look a little bit more reasonable, look more knowledgeable and more legitimate when you start figuring in faulting and things like that. So I think those numbers match. Now 3 dimes is 3/16 of an inch, okay? And you look at 8 dimes, that's 13/32 of an inch. So you're looking at a little bit, those aren't exactly humongous numbers to work with, so, and I think they're more legitimate. Next slide, please. And now I'm going to tell you right now on the slide is I have a mistake on it. I caught it and I resent it to DJ a minute ago so he can give it to y'all. The average numbers at the top of each one of these is the same exact number. I accidentally did that incorrect. The data that goes underneath it is still right though. And when we look at real time, when we look at this data on the 0.2 measures, the 0.2 to 0.4 stuff, now your real-time numbers are livable. Your post-processing numbers are livable, but truly, legitimately, the no minimum tie to joints is the most accurate and legitimate one. But you start looking at the real-time numbers based on these 0.2 measures and 0.4 measures, and there's a little bit more validity to the faulting numbers. It seems to make these numbers more reasonable and more acceptable. And I just sent the presentation back to DJ with the corrected slide. So if y'all want copies of it, just get DJ to send them to you so you can have them. Next slide.
Yeah,
here's a few.
We'll distribute it when we're done.
Huh?
I will distribute it when we're done.
Okay. Now, these are some of the issues that make me crazy. The items just annoy me. Every time I look at everything, it's a metric to English conversion, and I think we decided a while back that we're going to be English and not metric. So I can't understand why we're constantly trying to do 1 millimeter or millimeters to English. And every time you look at it, they get soft conversions. They'll do something like 0.3 meters equals like some other number that's not what it really is. They're rounding up, pretty serious rounding stuff going on. So I have a problem with that. The notice proposed rules and HPMS guide and the AASHTO guidelines and several other documents, they have terms and the proposed averages and proposed thresholds. Not only do they don't match, some of them completely contradict each other. So it's kind of annoying that you have all this stuff out there and they don't really define it in the rules. They just kind of say use this, and then you look at them and they all have a different definition or number. It's like what lane width or wheel path. There's like 5 different or 10 different numbers for wheel path widths, so things like that. I'm really burnt up about the large urban area things for RI, the adjustments for RI for large urban areas. RI is not affected by urban areas, it's affected by speed, traffic again. Once again, they say traffic doesn't matter what does. And the stops based on stop signs or signals. If you're riding down the highway and you get to catch a light, well, your RI is going to go to heck for a little while. Or if you get a short segment, you can't get up to speed. Those are the things that affect RI, not urban areas. So if you want to do legitimate things, track your, do traffic analysis based on that stuff. Compare it to that. Compare it to the real things that matter. Don't just make some urban area adjustment that doesn't seem to quite jive with reality. And then the question comes up on the faulting measure. Can we actually calibrate the data capture vehicle for the faulting measure? Because, right now when they do data calibration, we use real pavement segments, and they go and calibrate. And I think on faulting, they use some data from our LTRC facility that tells them what faultings are for those pavements, and they got to go and validate it. Well, when you do a wheel path and temperature type of measure, because of these low numbers, temperature affects the faulting and expansion of concrete, and then you start looking at the wheel path. Can you get the wheel path exactly the same every time you ride your 3 or 4 or 5 calibration runs? And can you match what the other guy ran? Because it might be different across the pavement. You're not getting a faulting across the whole pavement. You're doing it in the wheel path, so to speak, or maybe you are, I don't know. But what you're doing is I don't know how we can calibrate the vehicles at the calibration level. So I'm kind of asking, I want to have the feds to make sure that data capture vehicles can be calibrated for the metrics they're proposing, especially faulting. Next slide. Next slide, TJ. Okay. They state in the document, and I got clipped it out there, where in another part of the document they said 94% of the states monitor cracking percent. Well, that's what the NCHRP 401 document says. Really, that is not correct, because everybody has their own definition or formula for calculating percent, because you're not talking an apple comparison. Looking at when we explain our way of doing it, when they first started doing cracking percent, Chris picked up, he found a pavement with the most cracks, and said, okay, that's our base, and anything is measured against that total. So if you go over that total, you're still 100%. If you go below that total, some percent of that total. Well, you're talking about an area measure, like fatigue cracking is an area measure, and longitudinal and transverse cracking are linear measures. Well, your pavement segments area, so for the fatigue cracking, an area measure on area is a fine, you can come up with a percentage, but how do you calculate a linear measure and convert it to area measure, to get a percentage? Well, you need a defined formula and methodology, and they haven't given us that. So basically, you can make up your own methodology, and that's what everybody's been doing, and they're reporting it in the HPMS response. Everybody's reporting stuff that's not really apples to apples, so they're really not reporting percent cracking to be usable as it is, as far as I'm concerned, for comparable things. Percent cracking also conflates the data. What you're doing is you're taking you're forgetting about your severity levels, you're forgetting about all this other stuff, and you're combining it all into one measure and said they're all the same. Well, that's not legitimate. It's not. How do you come up? The whole thing about the rules, we're trying to get a better handle on what the pavements look like, but you're jamming this down into one little measure and saying that's what everybody is, and it's just not quite legitimate. You take out the severity levels and everything else, and it just seems to me to be, just you're trying to shoehorn a new way of doing things into the old way of doing things, and it just doesn't seem legit to me. I don't see anywhere where they indicate in the document how to determine spalling, okay? And I don't know what the hell other visible defects are either. If you look at that little printout, they got you're talking about spalling and visible defects. Well, okay, well, why don't you define what they are and tell us how to measure them and tell us how to report them. You know, just don't say other visible defects and spalling. So that kind of stuff. And basically, it comes down to this. You know, we're only going to capture what we have to capture and what we're mandated to capture, because most of us can't afford to do any more than that. So people who are just getting into this are not going to capture every single thing going on just because they kind of wishfully point it out to us. So we need to get a little bit better with that. Next slide. Another one of my little pet peeves is, you know, basically the rules say that jointed concrete panels, slabs, if it has one crack, it's 100% cracked. All right, well, tell me what the definition of a crack is. Well, you go to AASHTO, your crack is 0.04 of an inch, or that 5/122 of an inch, or 1 inch long, or a longitudinal crack's 12 inches, and so is a transverse crack. Well, the longitudinal crack only goes from 10 degrees to 10 degrees from the center line, so, and the transverse goes from 80 to 100. So what about that 70 degrees in between? What do you call those cracks? Would they just be a crack? So technically, what they're saying is the stuff in that 70 feet is basically, if you got a 1 inch long crack, your slab's 100% cracked. I mean, that kind of stuff. And again, 25 millimeters is 0.984 inches, and 3 millimeters is 11.82 inches. It's not 12 inches, and these rounding things are driving me crazy. So 2.5 meters is, they're claiming it's 8 feet, but it's actually 8.2 feet. You know, so you got these things like the AASHTO 5510 allows you to have a 2.5 meter survey strip or 8-foot survey strip, or you can use the full lane width of 3.6 meters or 12 feet if you choose. So if I take a survey strip and only use 8 feet, what about a crack outside at 8 feet? Does it count? No, it doesn't. So the standards are driving us crazy, but you need to comment about all this stuff. You need to look at all this stuff. And then what about severity? There's nothing about severity in the whole document. They, you know, and then I looked at the AASHTO road stuff, and they dropped severity for reporting too, because the severity thing was more of a, they said they didn't use it in their deducts in their performance when they're doing their performance on the long-term, what do you call it, where you're seeing the long-term performance of your roads, it's deterioration models. So they didn't use severity. Well, we basically use severity because we convert it to an index, and we deduct for different levels of severity, so we use it in our performance index, but it's just something to think about. All right, and how do they handle a seal crack? Well, the only time they ever reference the LTPP distress identification manual is in a footnote, and that's the only place in there where we'll talk about how to deal with seal cracks. So it's kind of, you know, it's kind of like just a little disappointing the way they did all this stuff. Next slide. Next slide, please. All right. They're asking us to include railroad crossings for RI. We don't own railroad crossings in the U.S. We can't touch them there. We can't get in there right away. You know, so kind of we always kind of mark it as a indicator that there's a railroad crossing there and take it out. What if you're missing data? What do you get? Bad stuff. And then DJ kind of went over the RI stuff for bridges. It's kind of complicated, and it's really not clear how to handle, like if you got a 20-foot, okay, I got a 20-foot culvert on a bridge. Well, that's technically a bridge in the U.S., so do we not count the whole RI for that? Do we not count that segment, or do we just not count the part on where the bridge is at? And how difficult it is to identify where the actual bridge is on a pavement in a 1/10 of a mile segment. It's pretty hard to do, so there's some complications involved in that. You know, construction zones, you know, what do you do with missing data? If I got a segment of construction, why should I get penalized for it? I'm fixing it, you know, and then you get the IRI capture issues. I mean, it costs a lot of money to circle back if you catch a traffic light, or if you got to pass a vehicle that's going too slow to screwing up all your data capture because it's too slow. You know, that kind of stuff needs to be addressed. In the long-term performance, there was a document that came out, FHWA HRT 14092, and it's the long-term performance automated faulting measurement. Just came out a couple of weeks ago. They said ProVal has a joint detection rate as low as 58%. Yet ProVal is the solution we're supposed to be using. So, you know, it has a number of issues too, and that kind of stuff. And then one of my really, really upsetting things is to find out that, you know, the feds have been working to remove structurally deficient from bridge definition for quite a while because the public's scared of public. You know, it scares the public. They don't want to ride on a bridge that's structurally deficient. They don't understand it means load posted, but you know, so they kind of got rid of the definition. They've been working to get rid of the definition, and now the rules bring it right back. It's kind of, you know, kind of disappointing that we have that situation. And that's it. Next slide is just my contact information if you want it. If you want to call me and ask me about things or talk about it. But you know, it's just I got like multiple pages of all this stuff, and I just try to condense it down into a few points for y'all to kind of look at, and then to kind of start building from, because we need to, you know, we need to pepper them with comments and get all these things out there and make them understand that they need to work a little bit harder on getting this right. So I'll turn it back over to DJ.
Thank you very much, Mark. Yeah, I'm glad you did a lot of that, because I know you spent a lot of time doing this, and you covered that better than I probably could have too. So at this stage, I was going to turn it over to a little bit of discussion here. And we have had, I think it was 2 comments come in that I'm going to talk about briefly. And while I do that, if anybody else would like to add anything, if you want to talk about where you are in the process, or if you had any additional questions, I'd be happy, or if you want to answer any of these questions that have come up, please just put a comment in or a question, and we can open up the microphone, so you're welcome to talk as well. As I said at the beginning, the goal of this is to try and get people talking to each other. So one of the questions came up from John in Oregon is, will we be talking a little bit about the documentation required for the quality management requirement? And this is a clear requirement that's part of the performance measures, where the FHWA is going to require a quality performance document, and they're going to have to get submitted to them, and then they have to approve it. So realistically, this problem gets split into 2 categories for the group of people on the phone. There's the people who are reviewing data that we collect and we provide, as well as those who are collecting their own data. For those of you who are reviewing the data that we collect and that we provide, want you to know, and I know we've had some of these conversations already, but we are working on creating our own quality management guide that will tell you how we do our quality management. And as many of you know, we do a lot of things from the moment we find out we're on a project to trying to set it up, to verifying all the values and settings on the ear end on a daily basis, and doing daily quality checks and controls, and then what happens when the data enters our office, how we do more quality control checks, and finally, you know, doing a final quality control review before it gets sent by a second independent person. So we have a very detailed process that we go through and we follow. And Fugro is actively working to assemble this document to make sure it's available to everybody. And from there, we've definitely had some questions from a few of the agencies. And once again, feel free, if you'd like more information, to contact your project manager or the customer support team. And we'd also be happy to help you discuss what additional quality control measures you should be doing after you receive the data from us. How we can work to help meet the controls process that many of you have set up, and how we can best document that, and the way that those are tested and the way you verify that data, as well as the type of testing and comparisons and comparing data between years even to verify that the data being received is correct. There's definitely a bunch of things that can be done. I know there are several agencies, some of whom are on the phone, who definitely already have some of these documents well underway, who have, even before the NPRM came out, who had documentation on exactly how they were performing this QC. And if you'd like some contact information, we can definitely help put you in touch with each other. If anybody now wants to speak up and talk about what they have and they would like to share, please just let us know. And that's definitely one way that we can be helpful in terms of generating that material. And obviously, we're more than happy to help you write some of that and discuss what we do for other people. Just contact us and let us know. For those of you who collect your own data, we're more than once again happy to provide that document to you. And in many cases, you're already doing many of those steps. Most of you have some sort of control loop or something similar to that you're already doing that, once again, just needs to be documented. Most of you already have some form of this plan. It's just putting it down in writing so you know exactly what you're doing. Because the FHWA and the NPRM is very clear that they don't want to see our manual. They don't want to see our document. They want to know that we're doing our part, but they want to be sure that you as a state are doing the checkup so that you have confidence and that you believe that we have done everything in our power to make sure you get the best accuracy. And they have put the responsibility on you, and clearly we want to take as much responsibility as we can to get you the best possible quality data. But they want to make sure that you have processes in place to verify that those indeed are the results. There was another comment in from Matthew in Iowa, just talking about some of Mark's numbers. We can definitely get you Mark's information, and you can chat with him about some of those data themselves. Clearly, we have all the IRI for all of those numbers. I don't think it's actually been anything that we've researched so far to date, and comparing the IRI based in these areas with faulting. But that is a very good point, and something that has come up in the past, that when you do have faulting, why do we care about faulting? And the most common reason is because it provides a rougher ride. And when you have a rougher ride, then isn't that just measured with IRI?
Well, one thing I want to point out too is that some of these measures that they're looking at, like faulting's directly related to RI. I mean, it's a pretty high correlation. So faulting and RI double measures, and some of the other things like some of the cracking things and some of the other stuff they're talking about are directly related to RI too. But the faulting numbers are so low, and I can send you the document that I researched all this stuff, but it appears that they're just using basically design criteria that they came up with a long time ago, and it had never been validated against real field data since before 1998. So it's kind of interesting.
And the last question we received is from Patrick, who asked, we are unclear how the NPRM wants to report percent pore cracking, and we are wondering how other states are doing this. Clearly this is why it's one of the more contentious issues, because pretty much every state has their own distress protocol. We're quite used to, at Fugro, dealing with a unique distress protocol from everybody. And there's definitely a whole bunch of definitions here. I'm going to try and do my best to give you 2 or 3, Patrick. But if there is some more details, once again, feel free to contact our team. And we have a good number of distress manuals handy on our side. The short version is, first of all, most agencies don't directly calculate a percent cracking variable right now. More often than not, once again, this gets split into 2 categories. Most of the ones who are doing fully automated are usually pretty much calculating the percent of data. If they're using the existing AASHTO standards, they're using the percent of data or the length of cracking in each of the 5 AASHTO road zones in the 3 severities as defined in the AASHTO standard, and they're doing it for longitudinal, transverse, and pattern cracking. And this pretty much produces a report with 45 numbers, none of which are percent cracking. Instead, they're the length of cracking in feet. So there are definitely some states that are just taking that and trying to estimate, based on if there is cracking in this portion of the road zone, where we're going to count the whole area of that road zone and calculating percent area this way. There are definitely some who are using the HPMS method, where they're only really looking at the fatigue cracking and just focusing on that. Those are probably the 2 most common ways. When we're actually manually drawing on some of the cracks using our semi-automated methodology, or QCing some of the fully automated data. In that case, we do have some more options. We can draw boxes around some of the cracks to determine a better example, but it's still very difficult to get an area for an individual crack.
Yeah, when I looked at Australia, there's like multiple different ways they're doing it. There's two agencies in Australia Roads Group, so it's like kind of like a bunch of 8 count, or I don't know how they break it down, but it's a bunch. It's New Zealand, Australia, and all that. One agency multiplies a linear crack by an area, and I think the other one does something similar. They use different measures, but so like if you got a linear crack and you multiply it by 3 inches on either side of the crack, you would get an extent. So then you went in an area for that extent of that crack, and your area to area is a percentable number. You can make it a percentage, but a linear measure for area, it's difficult to calculate a percentage, or there's no real mathematical construct that lets you do it. So that's a curious way to do it. There's an opportunity to look at it from that perspective too. So there's that makes a little sense. But it's kind of frustrating when you look at it, because and it's one document talks about zones and it's the width of the pavement. The other one talks about an 8-foot segment, and you're really measuring apples, or what are you measuring really? Wheel paths, there's like 10 different definitions of sizes of wheel paths. So, you need some kind of consistency. If it's in a wheel path and it's asphalt, it's fatigue cracking if there's no, composite pavement, but composite pavement cracking in the wheel path is not fatigue cracking. So what do you do? I mean, it's just kind of like, they're trying, like I said, they're trying to dumb down the data so they can report it, but it's kind of frustrating a little bit. And you don't use transverse cracking on, continuous reinforced concrete, but you do use it on other things like jointed concrete. So they got some complications, and they're trying to grossly simplify everything and jam it into one measure, and the measure doesn't make any sense. So I would suggest proposing that they do a little bit more, instead of just doing it like that. Update the HPMS and capture more information so they can have a better understanding of what they're really looking at. And somebody that was involved in the HPMS world told me that Congress looks at HPMS. So they're trying to use HPMS, the data from HPMS, and they kind of wanted to stay consistent so they don't get busted by Congress for changing the numbers so much. So sometimes you got to look at it from, they got a political bear to deal with too. So, but we got to get it right. We can't worry about how it affects them in Congress.
Thanks, Mark. At this stage, I do realize that we are over our 1 hour mark. Well, I'm pleased to continue to go on. I want to make sure that at this point in time, I do thank everybody, and I do realize you're busy, and if you have other obligations, feel free to drop out. But if there are more comments and questions, I'm going to be around for a little bit to stick around. Just one more comment that just popped up is somebody did note that the World Bank uses an area of influence, so pretty much for every crack, they assume that there's a 0.5 meters, so a quarter of a meter on either side of this crack, and that's what they use to combine to create this. To put it in perspective, that's somewhere just less than, 0.6 of a meter would be 2 feet. It's a pretty close assembly. So it's using almost a foot on either side of every individual crack. When you start talking about percent cracking and anything over 5% cracking, all of a sudden you start getting into the other categories. That is going to give some pretty high numbers, but that is relatively common. And as Mark noted, Austroads does have a couple ways to do this. And the equipment being used in Australia is very common. There's 2 real vendors who are doing data collection there, and one of which is using an ARAN with a paid 3D system. So just to keep in mind that they do have very, very similar systems that we do here. Right. I think that's all the questions that we've got so far. If anybody else has anything else they'd like to add, that's great. If not, I would definitely like to thank everybody. We will be following up to everybody who attended, and as well as some others who wanted to be here but couldn't make it due to other obligations. We've been recording this webinar, and we will make the recording available as well as copies of all the slides. We thank you for your attention. We're grateful that you could be here today, and we hope that we can keep this conversation going and see what we can do to to ensure that we get rules that are clear, concise, and that everybody can follow, and make sure that we're doing a good job of measuring the true condition of the network, because really that is our goal. So thank you, everybody. Thank you, Mark, for agreeing to participate today as well.
You bet.
Thanks all. Bye-bye.